in section 13.1. Just a reminder, this is 13.1 from the book. It is 14.1 in your math lab. Again, I don't know why the sections are off, but they are. And so this is 13.1 from the book, 14.1 in your math lab. And so we had been talking in the previous video about conversions, how to go from metric, different units in the metric system, the English system, and we've talked a good bit about that. And so we're going to begin incorporating distance into this chapter. We're going to go further later on into distance and the distance formula and some of those things. But some basic properties about distance that you need to be aware of. Now, the first one is that the distance between any 2 points, A and B, is greater than or equal to 0, written AB, that's the distance between A and B, is greater than or equal to 0. Basically, that means you cannot have a negative distance. And we know that. We know that when you measure, you talk about how far you've traveled, the unit you use is a positive unit. It's never negative. You never say, well, I traveled negative 4 miles. No, you traveled 4 miles, or you traveled 5 miles, but you never traveled negative anything, because we don't measure distance in negative units. And so that's going to be important as we move on, especially as we get into finding the distance between 2 points. You're going to see us use absolute value some, and the reason is to make sure that distance that we find is a positive. The next property says that the distance between any 2 points, A and B, is the same as the distance between B and A. So in other words, if you go, I've used this example before, but if you drive from your house to school, you may travel, let's say, 20 miles. Well, when you travel from the school back to your house, you still travel 20 miles. It's not negative 20 miles. Again, we don't measure distance in negative units. And so the distance from point A, we'll say, is your house to school, which is point B, is the same as it is from B to point A. Okay, so no matter which direction you go. And then the third property says for any 3 points, A, B, and C, the distance between A and B plus the distance between B and C is greater than or equal to the distance between A and C. And so we're going to see that when we talk about triangles. If you have these 3 points, the distance between them, between A and B and C, has to no less than, it can't be any less than AB plus BC. Now, it could be greater. If you happen to have a triangle, it would be possible to have it greater, but you can't have it less than that. And so again, we're going to see all these properties as we move forward. So, let's talk about triangle inequalities. And this is something we have mentioned before. I know in one of our, maybe in the last chapter, we talked about triangles a little bit. We talked about the idea of 2 sides have to add to be greater than the longer side in a triangle. And that's what this says. It says the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. In other words, if we take this side, AB, and we take the length of this side, BC, it has to be, if this is a triangle, it has to be bigger than the third side. Because if it were to be equal to the third side, so let's say this is AB, and let's say that this is BC, then that distance, the distance from C to A, so let's do this, A to C, if that distance is smaller, then you can have a triangle. I'm sorry, if that distance is, is smaller than AB plus BC, you can have a triangle. But if that distance is longer than AB plus BC, then these 2 pieces here, if you laid them straight out together in a line, Well, if this AC happens to be longer, then you're not reaching both endpoints. And so there's no way that ever becomes a triangle. And so the only way that you have a triangle is for the two smaller sides to add to be bigger than the third side. If it happens to be equal, then you have a line. You have all those points lying on the same line, and there's no way it can be less, which goes back to the previous property. So as we're talking about these properties and these inequalities and different things, we're going to be using a lot of this in problems later on through this chapter. So let me erase this so you can see the question here. The question says, can a triangle be made with sides of 15, 18, and 37? All right, so again, our two smallest, according to this inequality, have to add to be bigger than the third side. Well, 15 plus 18 is going to be 33. And 33 is not bigger than 37. And so the answer then has to be no. Because if you were to lay out this 15 centimeter piece and 18 centimeter piece, if you lay them just end to end flat, they form a line. Well, they don't reach the end point of this segment because it's 37 units, not 33. And so the answer here is no, that you cannot have a triangle. And again, I hope that makes some sense to you. If you have questions about that, let me know. I can always show you some additional examples. I can show you some illustrations that I think will help. So again, just let me know. You could play around with this. One thing I would encourage you to do, if you're not sure, go pull out a ruler and take maybe a 1-inch segment. So call that AB. And then from B, measure out maybe 2 inches. So where this is 1 inch, this is 2 inch, call this BC. And then take out a piece that is, let's say, 4 inches. Again, just as an example, and you can call that DE or whatever you want to call it. And you'll see that if point D and point A are on top of each other, point C never gets over here to point E, right? Because it's too long. And so you could play around with that and see some examples of where this inequality is true. I mentioned in, I think, chapter 12, that when I used to teach this in my geometry classes at the high school level, I would take straws, pieces of straw, and I would have students cut those and make their own triangle. And if they cut the pieces too short, where you had the two sides that were shorter than the third side, then they wouldn't be able to get a triangle because the pieces wouldn't all meet. And so, again, a lot of ways you can play around with that, hopefully to convince yourself that this is a true statement. All right, so the next thing we need to talk about is perimeter. And I'm sure you know what the perimeter is. It is simply the distance around a figure. So we think about finding the perimeter of a polygon. Usually we think about this as like a fence around a field or something. It is the length of a simple closed curve or the sum of the lengths of the sides of a polygon. Okay, so if it happens to be a circle, well, you don't have sides, you just have that one length, and we'll talk about that length later. But the perimeter, if you do have a polygon, you're just adding up all the sides. Okay, very easy number to find typically. And so this is a very basic measurement that you need to know how to find. So we want to find the perimeter of each of these. And hopefully this isn't a big deal. So if you want to find the perimeter of this triangle, you're going to take this side of 3, this side of 3, and that side of 3. You're going to add them all together, and that gives you the length all the way around the figure. And so when you do, you find out that it is 9 centimeters. Now, make sure that you do label the unit. If we know the unit, we need to label it, because if you just say 9, we don't know if you're talking about 9 feet or 9 miles or 9 inches or 9 centimeters or 9 meters or 9 kilometers. We don't know if you don't label it. So you have to make sure that on all these measurements, we're going to talk about area in a little while. When we find the area, when we find the perimeter, when you find any length, if you know the unit being used, you must use it. Okay, so just be aware of that. Now, that one's hopefully pretty simple. Look at the next one, though. We have this rectangle, and we know that the perimeter can be found by adding all the sides up, right? So if you take W, which is this side, and you add that to L, which is this side, and you add that to W, which is the other side, and then add that to the other L, then you'll have your perimeter. Now, we can simplify that a little bit. You know, from some basic algebra, you can combine like terms. So 2W plus 2L, or in other words, 2 times the W, because you have 2 of them, and 2 times L, because you have 2 of them, should give us our perimeter. Now, somebody say, well, what's the number? We don't know. We don't know W and we don't know L. This is how we're going to find it, though. 2W plus 2L. And so, if I told you, well, the length is 7 and the width is 4, well, then you can put those numbers in and you could find this perimeter. Again, if we don't know, we just use the letters that are given to us. And you're going to see that a good bit as we work through some examples moving forward. All right, so look at this one. We have a square. We know it's a square because we do have the right angle, and we also are told that every side length is the same length. And so based off of that, we know this is a square. And so the way we find the perimeter of a square is we just add up the side lengths, and they're all the same, right? And I hope you know, if you took real number systems, you learned about how multiplication is simply repeated addition. It's just adding over and over again. And so to add S plus S plus S plus S, which is each of these sides, well, that's just the same thing as saying 4 times that S. And so 4S is the perimeter here. Again, pretty straightforward, not a lot to that. Just adding the side lengths. But look at the next one. So notice here that this one is not done with the same unit measures, right? You've got centimeters for 3 of these. You've got millimeters for 2 of them. Well, before we can add these together, we need to make all of those units be the same, right? Because we know that a millimeter and a centimeter aren't the same. So if you were to add, let's say, for example, this side and this side, you can't say, well, that's 43 centimeters or 43 millimeters, because that's not the same. And so I gave you a chart in our last video, I believe it was, that told you that centimeters is 1/10 of a meter, and a millimeter is centimeter is 100th of a meter, and a millimeter is 1,000th of a meter. So essentially, a millimeter is 10 centimeters. Okay, so think about that. If you have 1 centimeter, and if you have a tape measure or a ruler handy, you can go find it. 1 centimeter is broken into 10 millimeters. And so it kind of looks like that. If you go pull out a ruler or pull out a tape measure, you'll see if it's got centimeters on it, a lot of times it will have 10 millimeters between each centimeter. So we need to convert all of these to the same unit. And because this happens to be 40 and 60 millimeters, you could convert it to centimeters. But if it had been 42 millimeters and 63 millimeters, well, then we can't convert that to centimeters easily. So what we're going to do is we're going to convert the centimeters to millimeters. Go to that smaller unit. That way, if we end up having odd numbered millimeters for these other two sides, we can still add them all pretty easily. And so if we do that conversion, this 3 centimeters is the same thing as 30 millimeters. And the 1 centimeter, which we just mentioned, is 10 millimeters. And 3 centimeters is 30 millimeters. Well, now we can add the 30, the 10, the 30, and then also this 40 and 60 millimeters, because now we do have the same measurements. And so when you add all those together, 60 plus 40 is 100, 30 plus 30 is 60, plus 10 is going to be 70, so 170 millimeters, which is the same thing as 17 centimeters. But again, we're using the millimeter, the smaller unit, just because if it had not ended in a 0, if it was not divisible by 10, you can't easily convert it to centimeters. So we're leaving it as the millimeters. And again, it is 170 of those. If you have questions about that, let me know. Just so you're aware, the 40 millimeters is 4 centimeters, and the 60 millimeters is 6 centimeters. And so in this case only, we could have added centimeters. You've got 17 of those. But again, we want to go to millimeters in case these numbers happen to be odd and, just kind of not easy round numbers ending in a 0, then changing to millimeters makes it a little easier. If you have any questions about that, let me know. I'll be glad to answer any questions that you have. So, look at this question. What is the perimeter of an n-gon with S sides? Regular n-gon with S sides. So, remember, an n-gon just indicates how many sides. If we say it's a 15-gon, well, that means the n would be 15, right? And if it's regular, it means all the side lengths are the same. And so to find the perimeter of an n-gon with S sides, we're simply going to take the number of sides, which is n in this case, times the side length S, and we're just going to have ns as that perimeter. And it's really what we did here with the 4S. With the square, you can see that the number of sides was 4. They were all the same length. We said 4 times S. If that had been 5 sides or 6 sides or 20 sides or whatever, then we would have still said that number times S if all those side lengths are the same. And so that's where the NS does come from. Again, questions about perimeter, shoot me an email, let me know, and I'll be glad to answer any questions you have. All right, so let's talk about the circumference. So the circumference is basically the perimeter of a circle. Okay? It is a set of all points. Well, let's define a circle. Again, I just assume you know what a circle is, and you do, I know that. But let's define it. So the circle is a set of all points in a plane that are a given distance from a center point. And you can see in the diagram here your center. And what you see in red is the circle. And every point along that circle is the same distance from that center point. Okay? I was teaching about circles in an algebra class this semester, actually. And I mentioned that my wife and I had a pool put in about 3 years ago, I guess. And it's a circular pool. And so when they came out to install it, they asked me where I wanted it to be. And I told them, how far I wanted off my back porch and all this stuff. And so they found the center. Let me back up. So they found the center of where that circle should be, and they stretched a string out some distance, and then they took that string and they pulled it all the way around until they got back to where they started. Now, mine's an oval shape there. It's not a good circle. The point is, though, every point along this line, or I'm sorry, along the circle, was the same distance because they started out with this length. And as they pulled it all the way around that point, every point on that circle was the same length. And then once they had it marked, they began to dig, right? And so when they dig that out, they're able to dig out that perfect circle to put the pool. And so when we define a circle, it is all these points that are the same distance from that center point. Notice the center is not part of the circle. Okay, that's important because when we talk about the circle, we're only talking about the outside part of it. The center is not part of it. Now, the circumference is basically the perimeter of the circle. It's the length of that circle all the way around it. Okay, again, we talked about the perimeter being the measurement of the outside edge. Again, think about it like a fence. Well, if you had a circular fence, how long is that fence? Okay, that's what we're wanting to know. And so to find the circumference, we're going to have to use a value of pi. Now, pi is the ratio between the circumference of a circle and the length of its diameter. Okay, it's a value, it's an irrational number, but it is a number that we use a lot dealing with circles. And so that brings us to our circumference formula. So the value of pi is approximately 3.14. It is not exactly 3.14. It is, again, an irrational number. It doesn't repeat. It doesn't stop. There are people that spend years and years and years trying to figure out the next decimal place in that value of pi. And it goes on forever, and I've seen people that will, especially math teachers, that'll print it out, and it goes all the way around their room because that decimal never stops and never repeats. And so it's a very, very long decimal, but we round it to 3.14. It is approximately 22 over 7. Again, that's not exact. That's just an approximation. And so we will use pi. We won't use the approximation. Okay, so when you start doing some of these calculations with your calculator, there's a pi button. I believe it's on the left-hand side. I'm trying to think where it is on your calculator, and I don't remember right off. But there is a pi button. Okay, this is the symbol of pi. Again, I assume you know that, you've seen that. But you'll use that in some of these calculations. So to find the circumference, we use pi times the diameter, or 2 pi r. Okay, so the diameter is this length all the way across the circle, going through the center. The radius is only half of that, from here to that outer edge. So when those people were putting in my pool and they stretched that string out from the center, well, they stretched it out the length of the radius, only halfway across the circle. If you go all the way across through the center, then it is called the diameter. And so since the diameter is 2 times the radius, that's where the 2 pi r comes in. Okay, so just be aware of that as we work through a few of these. Another formula that you need to know, and there are several formulas here. I'll post information about formula sheet. I may give you a formula sheet to use on your test. So we talked about measurement of an arc previously, and it being equal to the central angle. Well, here we're wanting to find the length. How long is that arc? And so we find it using this formula. Now, this symbol we call theta, And that is going to be the measurement of our angle. So again, you can see in the diagram here, theta is the angle measurement. We have to use that to be able to find the length of that arc. Okay, so we're going to use that formula in just a minute. So let's look at a couple of examples. Actually, I have 4 parts here. And the first part says that we're going to find the circumference of a circle with the radius of 2 meters. Now, again, circumference is pi d or 2 pi r. And we'll use the arc length in just a minute, and I'll write that down when we get there. So if we're going to find the circumference of a circle with a radius of 2 meters, well, based on our formula, since we have the radius, we can use 2 pi r. And so we're going to say, well, the circumference is 2 times pi times the radius, which is 2 in this case. And so we'll multiply 2 times 2, and we get 4 pi. And again, we want to use the exact number, and pi is going to be the exact number. So 4 pi meters is going to be our answer. So you can see that there. Again, just using that formula. Hopefully it's not a huge problem. Look at the next one. It says the radius of a circle, so we're wanting to find the radius of a circle with a circumference of 15 pi meters. Well, again, in our formula, it says their circumference equals some stuff, right? Well, if our circumference is 15 pi, and that is equal to pi d, then that means our diameter must be 15, right? Because it's diameter times pi. And so this implies that the d is equal to 15, the diameter. And we know the radius is half of that. And it asks for the radius in the problem. So half of 15, or 15 divided by 2, is 7.5, and it is meters that we're talking about. And you can see that pop up right there where I wrote it. So I can give you the radius, I can give you the diameter, I can give you the circumference, and ask you to find one of those missing values. Now, part C and D deal with arc length. And so again, our arc length formula is pi r theta over 180. And so the first one says to find the length of a 25-degree arc of a circle with a diameter of 10 centimeters. So our length can be found by taking the 25 degrees, which is the theta. The diameter is 10. Well, this formula uses the radius. And so the radius is half that diameter. And so if we substitute those numbers in, we have pi times the radius, which is 5, half of 10, times 25 over 180. And so we can simplify that a little bit. Excuse me. So we'll have 125 pi divided by 180. And that does simplify. The 125 and 80 will simplify. So 5 goes into both of those. 5 goes into 125 25 times. 5 goes into 180 36 times with pi left. And so again, we get that length, and we are talking about centimeters, so I need to make sure I add my unit here, so let's do that. And so we get 25 over 36 pi centimeters. Again, just using the formula, putting that in. Again, you can see I've written over where that shows up. But it is 25 pi over 36. And if you do punch that in the calculator, you'll see that it's about 2.18 centimeters. Again, that's not an exact number, but that is an approximation. If you have any questions about that one, let me know. Be glad to answer any questions you have. Now, look at the next one. So the next one says that we want to find the radius of an arc whose central angle is 87 degrees and whose arc length is 154 centimeters. Now, again, if we go back here and use this formula, okay, and I'm going to do this at the top just to give me some room. The formula says that our L, which is our arc length, is equal to some stuff. Well, we're given the arc length. We're told it's 154 centimeters. So in our formula, we can put in that 154. We know pi is a number. We're looking for the radius. We don't have it yet. And then our theta is 87 degrees. And it's divided by 180. Now, if you're wanting to solve for r, trying to get r by itself, first thing I would suggest is multiply both sides of that equation by 180. That way, when you do, the 180 on bottom and the 180 multiplied by cancel out. And again, punch it in your calculator. You'll see that 180 times 154 is 27,720. And it equals to 87 pi r. Again, just that stuff that's on top. Well, again, we're trying to get r by itself. So if you divide by 87 pi, that's going to get r by itself, and we got to do that to both sides. And so the 87s cancel, the pi's cancel. It does leave us with r. And if you punch this in your calculator, the 27,720, if you take that and divide it by 87 pi, put that 87 pi in parentheses. That way that gets multiplied, and then you're dividing. And when you do, you'll see that it ends up being approximately 101.4 for the radius. And again, it's not equal, it's approximate. So we use a little squiggly equal sign. And again, you can see that at the bottom of the screen. So I believe this takes us through the end of section 13.1. It does. And so we're going to stop the video here. Our next video will cover section 13.2. If you have any questions about any of this, let me know. Be glad to answer any.